All right, ladies and gentlemen, welcome to the video notes for Chapter 6, Section 2 in your McGraw-Hill geometry textbook, the section is entitled Parallelograms. Chapter 6 is all about quadrilaterals. So before we get into parallelograms, I do want to do some background notes real quickly on quadrilaterals. First of all, I want to add an official vocabulary definition for quadrilateral. A quadrilateral is herefore described as a four-sided polygon. There are a number of types of quadrilaterals that you've dealt with throughout your time in school. You have learned throughout elementary and middle school about these shapes: parallelograms, rectangles, rhombus, plural of which is the word rhombi, squares, trapezoids, and kites. Okay, we are going to talk about all of these throughout the chapter, but what I wanted to do is I wanted to give you a visual representation of quadrilaterals in general in the form of a Venn diagram. So this box contains all quadrilaterals. Every four-sided polygon can be placed somewhere in this box. Now within that are several more specific types of quadrilaterals, starting with the parallelograms, which is what we're going to talk about first in this chapter. Okay, and within the parallelograms are several other even more specific types of quadrilaterals. Every rectangle is considered to be a parallelogram. Every rhombus is considered to be a parallelogram. And where they overlap, well, those are a special type as well, which you've probably spent more time studying those than any of the others. Those would be your squares. Now, in addition to talking about parallelograms and their specific types, rectangles, rhombi, and squares, we will also discuss two additional types of quadrilaterals: the kites and the trapezoids. And within the trapezoids, we will discuss the idea of an isosceles trapezoid. Okay, so there's a Venn diagram representing all quadrilaterals. Now, all quadrilaterals have several properties, the first of which being they're quadrilateral, so they have four sides. In addition, every quadrilateral has the same interior angle sum. Since the number of sides in every quadrilateral is equal to 4, the angle sum, which can be given by the equation S equals 180 times n minus 2, as we discussed in the previous section, that would be 180 times 2, meaning that every single quadrilateral adds up to 360 degrees. So here are several quadrilaterals down below for me to illustrate how that is. If we draw in the diagonals in those shapes, okay, we have two triangles in each of those shapes, which is why we get 360, because we have 180 degrees for each triangle, which would be a total of 360 degrees. Now, I had somebody ask me in class, well, why don't we draw in both diagonals? So if you draw in both diagonals, that creates angles out here in the middle of the shape, and those angles would not be around the outside. Remember, we're talking about the sum of these outside angles. So we don't want to consider any angles formed in the middle. That's why we only connect one vertex to every vertex it's not already connected to create the number of triangles that would make up the entire shape. And in every case, it's two triangles. Okay, so now we get into parallelograms. Parallelogram is defined as a quadrilateral with two sets of opposite parallel sides. So here we have a quadrilateral where AB is parallel to CD, as indicated by these triangles, and BC is parallel to AD, as indicated by this set of two triangles. The reason I'm drawing two triangles on BC and AD is they're parallel to each other, but not to AB and CD. So what we're saying here is if AB is parallel to CD and BC is parallel to AD, then this quadrilateral, which we would name by going around the outside, ABCD, is a parallelogram. Okay, so new vocabulary. Parallelogram is defined as a quadrilateral with two sets of opposite parallel sides. Now what we're going to do in this chapter is we're going to discuss the properties of parallelograms, and then we are going to go through some problems illustrating those properties. So the first property that all parallelograms have is that opposite sides of every parallelogram are not only parallel, but they are also congruent. So here we have markings indicating that X, Y, Z, W, or W, X, Y, Z, however you want to name it. This quadrilateral is a parallelogram as indicated by the parallel markings. What this property is saying is that WX must be congruent to YZ and XY has to be congruent to WZ. They are always congruent. Opposite sides are congruent. Our second property is that opposite angles are congruent as well. Now we need to get used to the idea that we're probably going to have to use three-letter method to name these angles. So when I mark these angles, you're probably thinking, oh, angle M and angle P. Yes, but we're going to use the three-letter naming method. So angle NMQ is the lower left angle, is congruent to angle NPQ. And in addition to that, angles N and Q are congruent as well. So that'd be angle PNM is congruent to angle PQM. Opposite angles must be congruent. The third one, in my opinion, is the easiest for us as at this point geometry to understand, and that is that consecutive angles in this shape must be supplementary. They must add up to 180 degrees. And I feel like coming off of our chapter on transversals, this is extremely easy to understand. What I'm saying is the measure of angle A plus the next angle in the, as we go around the outside, which would be angle B, must be 180 degrees, which makes sense because they are consecutive interior angles, and parallel lines being cut by transversal, consecutive interior angles are supplementary. So we've got four total statements that we need to write out here because it could be any two consecutive angles, so B and C add up to 180. Measure of angle C plus the measure of angle D is 180 degrees, and the measure of angle A plus the measure of angle D has to be 180 degrees. Okay, any two consecutive angles must be supplementary. Third, it requires a little bit more vocabulary. The fourth one does, so we need to do the idea of a diagonal. A diagonal is a line segment in a polygon which connects two non-consecutive vertices. So the red lines in this picture, GJ, is connecting G and J, which are non-consecutive vertices. That makes it a diagonal of this quadrilateral, GHJK. Okay, so it's a quadrilateral, GHJK. It is a diagonal of that shape. The same could be said of HK. HK is also a diagonal of that shape, GHJK. The reason why we care is because property number 4 of parallelogram says that the diagonals must bisect each other. Now when we say bisect, everybody should know what that word means. What we're saying is they cut each other in half. They cut into equal pieces. So in this picture we're saying that BE, I'm sorry, you know what, we should not say it that way. Okay, we're saying that BD bisects AC, meaning it cuts AC in half. What that tells us is AE is congruent to EC, and it tells us that E is the midpoint of AC. So it's a very valuable tool, okay, in this mathematical process, it's telling us that BD is cutting AC exactly in half, meaning that AE and EC are congruent and that E is the midpoint. And the exact same thing can be said in the other direction. AC also bisects BD, which means that BE is congruent to ED, and E is the midpoint of BD. Okay, so all those things are true because it is a quadrilateral. And I'm going to clean up this congruent marking just a little bit because I don't feel like it's very clear. Okay. And then the fifth and final property of a parallelogram says that a diagonal, any diagonal, either one of them, divides the parallelogram into two separate congruent triangles. Okay, and that's pretty easy to see because we already know that we have parallel lines, right? If we have parallel lines, that gives us alternate interior angles because BD would be a transversal. That would mean that angle ABD and angle CDB must be congruent because they're alternate interior angles. And angle CBD and angle ADB have to be congruent because they're alternate interior angles. Then we've got that reflexive side. Well, there you have angle side angle congruence. Okay? So what we're saying here, and this is valuable to us, okay? Triangle ABD has to be congruent to triangle CDB, which is valuable to us because corresponding parts of congruent triangles have to be congruent. So if we know the triangles are congruent, then we could set any two pieces of those triangles congruent to each other, equal to each other. Okay, so what you're going to see basically two types of problems on your 6-2 homework. The first type will be completing congruence statements. So in this picture here, first of all, there is a typo. This is supposed to say AD, not AG. So please make that change before we start the problem. All right, so the first problem says DAB, angle DAB is congruent to angle what? So what we should think to ourselves is we should think of the picture without the diagonals because we don't need the diagonals in this problem. Angle DAB is here, and all opposite angles are congruent, which means we should be looking for opposite angles. So we would say angle BCD. And that's how we need to think. We need to think of the picture with only what we need to answer the question. So on the next one, when we look at that parallelogram and we're asked about angle ABC, again, we do not want to draw the diagonals in our picture. Angle ABC is this angle here. Our properties say it has to be congruent to the angle opposite, which would be angle ADC. Same thing can be done with side lengths. So on the next problem it says BC is congruent to what? Well, BC is a side length. And if we're looking at this quadrilateral, BC has to be congruent to its opposite side, AD. Same thing can be done with parallel. Okay, if we're looking at this picture, if this is a parallelogram, it's asking us which side is parallel to AD. That would be the opposite side, which would be BC. And then finally, the last one does deal with the diagonals. So we have this picture here where we have A, B, C, D, and G is where they cross. Well, AG is half of AC because BD is cutting AC in half, which means that AG would be congruent to GC. The other type of problem we might see is when I give you actual numbers and I ask you to find missing lengths, missing angle values, etc. So for instance, BC, well that one should be relatively easy. BC has to be equal to AD or 12 units. Why? because opposite sides are congruent. Okay? Again, in your notes, you should be writing down enough information that in 4 or 5 months, when we go back to study for finals, we remember how to do these problems. So AB is similar. AB is one of the side lengths. It has to be equal to CD, which would be 7 units. Okay, same reasoning. Opposite sides have to be congruent. Okay, then we have BG. Well, BG has to equal GD because the diagonals bisect each other. GD is listed as being 5.8 units, so BG has to be 5.8 units because the diagonals bisect each other. Which means that BG is congruent to GD because G has to be the midpoint. Okay? AC, well, that one is a little bit more challenging. We should recognize that it has to be twice the length of GC, or 2 times 7.9, which would be 15.8 units. Okay, we should be able to get that using the segment addition postulate because AC is AG plus GC, and AG has to equal GC, right? Because that to be congruent, they're both 7.9. So 7.9 plus 7.9. Okay, because again, the diagonals bisect each other, which gives us that. BCD is one of the angles. It is supplementary. It is the angle BCD would be 180 minus the measure of angle ABC, which is 180 minus 110 degrees, or 70 degrees, because consecutive angles are supplementary. Okay, BAC is probably the hardest one. BAC is a little bit difficult because you have to recognize the alternate interior angles to realize that this angle here is 24.5 degrees. And then the 3 angles in the triangle have to add up to 180. So BAC would be 180 minus the 110 for angle ABC and the 24.5, which would leave us with 45.5 degrees. And last but not least, angle ADC, well, that has to equal the measure of angle ABC, which is given in the problem as being 110 degrees. So lots of different ways, lots of different approaches, lots of different possibilities for the problem setups. Make sure you take your time and you recognize which property you're using in each parallelogram. Good luck on your homework. Thank you very much for your time and attention.